Welcome to NASA Edge, an inside and outside look at all things NASA. Joining us on the show today is Kurt Leucht, who's an old friend of NASA Edge that we've worked with for many years, but we wanted to get an update. Kurt, thanks for coming on the show today.
Blair, thanks for having me. It's a real honor to be on your show again.
Well, I tell you, I'm excited too because I hear you're working on a new project that's going to the moon, and based on our experience, this is kind of expected, but we want to know more details. What are you working on these days?
We've been working on an excavation robot, and your viewers probably know that NASA has been working on the Artemis program, which is going back to the moon and going to the South Pole this time. And this time we're going to be staying and living and working there for long duration, sustained human exploration missions. And in order to do that, we're going to have to live off the land and use some of the resources that are there. We call that ISRU, or in situ resource utilization. One of the first stages of ISRU is excavation, or digging up the regolith. Not only can you use that moon dirt, that regolith, for construction purposes, but there is actually ice, there's water trapped in that regolith underneath the surface, and we will be able to use that water. There's actually a lot of water trapped on the moon. So we're working on an excavator that we think is capable of excavating on the moon in low gravity. And that's not easy. You think of the excavators that we have here on Earth. They're very large, very heavy machines, and they use their size and their weight to help them dig. And that's going to be difficult for us to send very large, very heavy excavators to the moon. So we're working right now on an excavator that is going to fly to the moon probably in the year 2024. We call it the Lunar Pilot Excavator. And pilot in this context means experiment or test, not somebody who flies an airplane. So this is a test excavator. It's a very small excavator designed for low gravity. The size of this excavator is about 2 feet by 2 feet by 2 feet. It's kind of about the size of 2 carry-on bags that you set on top of each other. That's about the size of this rover. It's not very big. What our mission is going to be is a technology demonstration mission, a tech demo. If it works, then we'll be able to move on to a more operational mission that will be excavating in support of an actual ISRU human sustained mission in the future to support long-term human exploration missions. We like to think of our robot as a different class of robot than what we've sent off-planet in the past. We're not saying it's better than other robots that have been sent out there to explore the moon or to explore Mars. It's just a whole different kind of robot. Ours is, we like to think of it as a blue-collar robot. It's going to excavate a lot of regolith. And when I say a lot, in the past, all of our robots that have dug up regolith on the moon, they've only collected just a few kilograms of regolith. But our Lunar Pilot Excavator, when it goes to the moon in 2024, it's not going to excavate 10 kilograms, it's going to excavate 10,000 kilograms. I mean, we're talking many orders of magnitude more than has ever been tried in the past. And that's not even the best part. The best part is how much we're going to drive. The Mars Opportunity rover right now holds the off-Earth driving distance record of 45 kilometers. In its 15-year mission duration, it drove 45 kilometers, which is an amazing feat. But Opportunity was a science robot, not a construction worker robot. Our robot, we're going to drive 150 kilometers. And the best, that's an impressive number, but the best part is the time that we're going to do it in. Opportunity did that in during a 15-year mission. We're going to do that in 11 days. 11 days.
Wow.
We're going to drive, wow. We're literally going to drive circles around the lander, and we're going to excavate and dump and then drive more circles around the lander. We're going to see how far we can push this rover and how strong it is, how tough it is. It's a different kind of mission. Instead of exploring slowly and carefully for science, our mission is to be a workhorse. We're going to work hard, we're going to work fast, we're going to get beat up, And hopefully, if we've designed it right, we'll be able to keep operating. It's just a completely different kind of machine than NASA has built and flown in the past.
Well, we're very excited to hear all about the Pilot Lunar Excavator. And Kurt, thanks so much for being on the show today. We look forward to hearing more, but we also, when it launches, look forward to seeing that little regolith cloud kicked up when we look at those full moon shots from the Earth, because it sounds like you're going to be doing a lot of work.
It's going to definitely be kicking up a lot of dust. I don't know if you'll be able to see it from the Earth, but we'll do our best. We'll try.
We love having you, Kurt. Keep up the good work, and we look forward to great things from you guys down at SwampWorks.
Ooh, can I do the tagline?
Sure.
You're watching NASA Edge, an inside and outside look at all things NASA.